Welcome students. We have studied about hydraulic press and pressure of fluid and also the some problems on YouTube. Okay. So today we will study on Archimedes principles and some phenomena of hydrodynamics. So we all know the principle Archimedes principles that the if a body partially or fully dipped into the fluid at rest, the fluid exerts an upward forces of buoyancy equal to the weight of the displaced water. Okay. The upward force is called upthrust or buoyant force. Okay. And this buoyant force is equals to the weight of the displaced liquid. Here is a proof that if a body, let us consider a body which is fully dipped with its length is L and cross-sectional area is A, then the pressure at the upper head of the body is H1 rho g and pressure at the lower surface of the block is H2 rho g and force F1 will be H1 rho g into A plus P naught. P naught is the atmospheric pressure. Okay. And F2 will be H2 rho g into A plus P2 into P naught into A. Okay. As H2 greater than H1, that means F2 greater than F1. F2 will be the upward force and F1 is downward force. So net upward force is F equals to F1 minus F2. That means A sigma G H2 minus H1. Sigma is the density of liquid. That means force equals to V sigma G. V in sigma G. V in is the volume of the body submerged in the fluid. Okay, which is equals to A into L. L is the height and A is the cross-sectional area. Hence, upthrust equal to the weight of the fluid. That means V rho G is the weight of the fluid. So, principle of floating. When the body or a body floats on a liquid or submerged into the liquid. When if I take a container and body is immersed into it, then gravitational attraction force mg, which equals to v rho g, rho be the density of body, and okay, is act downward, and another upthrust or buoyant force is upward, which is equals to v sigma g. Okay, the sigma is the density of liquid. Then the net upthrust force or upward force will be v sigma g minus v rho g. If v sigma g greater than v rho g, then body will float. If v rho g greater than v sigma g, then body will immersed. Okay, this is the main phenomenon. These are the two cases. Okay, and in second case, when rho equals to sigma, when rho equals to sigma, that means density of solid body and density of liquid is same, then the body can float just emerging into the water. Okay, fully submerged into the water, and sorry, water, any liquid, you can take any liquid, it will be in natural equilibrium. If we got some slightly dipped the body, okay, if I take the body here, then it will also in equilibrium. If I take the body here, it will also take it will be also in equilibrium. Okay, that means all the position of the body is in equilibrium. That means apparent weight will be zero. This is the three phenomena I have explained. Okay, so according to this Archimedes principle, that upthrust or buoyant force equals to the weight of the displaced liquid. By this, we can calculate some properties of solid body. First property is the measurement of density of solid body, which is density is greater than the density of liquid. If I take a solid body which is completely submerged into the liquid, as the rho greater than sigma. Okay, here rho greater than sigma. That means V rho g is a downward force and V sigma g is the upward force. So apparent weight will be, that means what, if I take W test will be P rho G minus D sigma G. Okay. And actual weight we can measure W will be P rho G. Okay. Apparent weight you can say inside liquid. Okay, inside liquid weight. V rho G minus V sigma G actual weight. And weight loss W minus W dot equals to only V sigma G. If I take W minus W dust by W, then V sigma G by V rho G. V and G will be gone, and rho will be W sigma by W minus W. So by knowing the density of liquid and the actual weight we can measure in air by any instrument, weight measuring instrument, and apparent weight also measured into the can be measured by the of the block by some instrument. Then we can find the density of this solid body. Here is the beauty of that, we can take any shape or size of solid body. The calculations of amount of material available in alloy. So Archimedes first able to find the how much impurity available in a solid substance, okay, without breaking the substance or differentiating the materials from the alloy. Okay, so how he had done we will show you. Okay, so we have to take some liquid which density is known to us, so sigma, and a alloy material is taken. Okay, alloy material. So at first we have to measure weight of alloy in air equals to W naught. Weight of alloy in liquid equals to W. Okay. Then weight loss will be W naught minus W. Then this weight loss will be the E sigma G. Here is the volume of total alloy substance. Then V will be W naught minus W by sigma G. Then if let in this alloy the amount of mixed materials are M1 and M2. Let us take having densities rho 1 and rho 2 respectively. So this alloy material contain the mixture of two material having masses M1 and M2 and densities rho 1 and rho 2. Then the volumes are V1 will be M1 by rho 1 and V2 will be M2 by rho 2. Then now we know the weight in air W naught. This is will be M1 plus M2. That means M1 plus M2 into G is the weight in air, which is equal to W naught, which is measured. We don't know till M1 and M2, but we know W naught and G. That means M1 plus M2 will be W naught by G. This is the one equation. And another is the volume. Wait, the volume of the alloy. This will be V1 plus V2. And then V1 plus V2 will be V. Okay. Then V1 will be M1 by rho 1 plus V2 will be M2 by rho 2 equals to V. That means W naught minus W by sigma G. This is the equation number 2. By solving this equation, we have all known except M1 and M2. W naught is known to us. W is known to us. Okay. Rho 1, rho 2 should be known to us. Okay. Then we can calculate M1 and M2. Okay. So by solving this, if I take M1 from here, W naught by G minus M2, then put this that W naught by G minus M2 by rho 1 plus M2 by rho 2 equals to W naught minus W by sigma G, or M2 into 1 by root 2 minus 1 by root 1 equals to W naught minus W by sigma G minus W naught by rho 1 G. Then M2 is calculated, W naught minus W by G minus W naught by rho 1 G into will be rho 1 rho 2 by rho 1 minus rho 2. Similarly, we can calculate M1, that W naught minus W by sigma G minus W naught by 2G into rho 1 rho 2 by rho 2. Okay. By this calculation, we can calculate how much amount of different material available within alloy. Okay. In case of floating, there is another equilibrium we need. This is called rotary equilibrium. This rotary equilibrium is very important to make boat or any ship. Okay. So for a floating body, if a body is floating, here G be the center of gravity and B is the center of buoyancy. Center of buoyancy means through which the buoyancy force is working upward, and center of gravity is the center through which gravitational force is working downward without rotating the substance. Okay. If I slightly tilt the body, okay, then the center of gravity till now at its own position, but center of buoyancy changes to position of B dash. Sorry, this is not B dash. B dash is the, this is, okay, center of buoyancy changes to position B dash, and the vertical line through center of buoyancy and the previous vertical line meets at a point. This point is known as meta point, okay, or meta center. If meta center is the above the center of gravity, then body will reverse back to their initial condition. If that means body tends to bring back to its original position. But if the meta center is goes down below the center of gravity, then body will topple. Okay, that's why a wooden log cannot be made to floating vertically in water, or a boat is likely to capsize the sitting passenger stands on it. This is the all above Archimedes principles. Here one question is taken. So the question is, a vessel contain oil density 0.8 gram per cube over mercury density 13.6 gram per cube. A homogeneous sphere floating with the half of volume immersed in mercury and other half in oil. The density of material of the sphere is. So we have to find the density of material of this sphere. Okay. So half volume is within mercury and half volume is within oil. That means the sphere is now in equilibrium condition. Okay. That means the V rho G, if rho with the density of sphere, V rho G is acting downward, and and the upward forces are, if density of mercury is sigma m and density of oil is sigma O, then V by 2 sigma m into G plus V by 2 sigma O into G is acting upward. Here V by 2 is taken because the half of the sphere is immersed within a mercury and half of the sphere is immersed within oil. So I have taken V by 2. So in equilibrium, that means the upward force is equal to downward force. That means V rho G equals to V by 2 sigma m plus sigma naught or sigma O into G. And VB will be cut out, and rho will be, and G also will be cut out. Rho will be sigma m plus sigma naught by 2. Sigma 80.8 plus 13.6 by 14.4 by 2, means 7.2 gram per centimeter. Okay, the C will be answer. There are some conceptual questions. Why a small iron needle sink in water while large iron ship floats? Some questions you can read. If you have any doubt, you can tell me on doubt class. Sorry, live class. So now we will starting on hydrodynamics. Here we will study on flowing of fluids. There is two types of liquid flowing. Okay, one is called streamline flow and another is turbulent flow. Streamline flow is the slow motion flowing. Okay. When the liquid layer are flowing very slowly, so that if I take the liquid, it consists of several layers, number of layers. These are the layers. Then each layer is not mixing up with the another layer. This type of flowing is called streamline flow. By definition, streamline flow is the liquid that flow on which each element of liquid passing through point travel along the same path with same velocity as preceding element passing through the point. In streamline flow, that means each layer of the fluid is not mixing with the any other layers. And here also there is a velocity difference of these layers. The maximum velocity is central layers and minimum velocity is the layer at the side of container or pipe. But they have constant velocity. If center layer have maximum velocity, that means always center layer has maximum and constant velocity. And okay, in case of turbulent flow, if we increase a velocity speed of the liquid flow after a certain velocity or above a certain velocity, the liquid layer is not parallel to each other. They started mixing up with one layer to another layer. Okay, this type of flow is called turbulent flow. There is a two type of flows. This is the two type of flows. Okay, so critical velocity and Reynolds. Critical velocity is the velocity below which the liquid follow the streamline motion and above which liquid follow the turbulent motion. And Reynolds number is a number which define the fluid turbulence or streamline. Okay. Reynolds number is defined that the inertial force per unit area by viscous force per unit area. Okay. So the inertial force is rate of change of momentum and viscous force is the force due to viscosity. Viscosity is the another property of fluid which we will discuss in next class. Okay. So inertial force is the force between two relative layers. If I take two layers of liquid, then if the layers are flowing with velocity v, then inertial force will be v dm dt, v dm by dt, and dm dt will be v a rho. This is the inertial force. If I take inertial force per unit area, then v square arrow v a v square rho. Okay, v square. This is the inertial force per unit area, and viscous force per unit area we will discuss on next class. That viscous force will be eta a dv by dx. Dx is the distance between two layers. Okay. dvb is the velocity difference between two layers. If upper layer has v velocity, lower layer has v minus dv velocity or v plus dv velocity, then this velocity difference is the dv, and dv by dx is the velocity gradient. dv by dx is called velocity gradient, and force is the eta a dv by dx. And the dx is here written as r, and dv is written as here v. Okay, that means viscous force per unit area will be eta v by r. Then by putting on this, we can find the Reynolds number, that v rho r by eta. If Reynolds number is 0 to 2000, then flowing is called streamline motion. If Reynolds number is between 2000 to 3000, this flowing is called unstable or changing. Okay, from streamline to turbulent flow. Above 3000, the liquid flow is completely turbulent. So Reynolds number is the number which can define the flow is turbulent or streamline. Equation of continuity. Here we taken that the liquids are incompressible. So if I take a pipe of different cross-sectional area, then but rate of volume of liquid flowing per unit time is constant for each area. So in smaller area, the volume of liquid flowing per second will be V2 into A2, and at larger cross-section area, the volume of liquid flowing per unit time will be V1 A1, and this V1 A1 must be equals to V2 A2, because no fluids are incompressible, and no fluid is, this is the relation, V1 A1 equals to V2 A2. This is called equation of continuity. So due to this equation of continuity, we know when the water is just immersed from a tap, its velocity is lower, okay, small velocity, but due to gravitational attraction force, velocity gradually decreased. Then as velocity increased, as velocity increased, so the area of cross section gradually decreased, so that it maintain the equation of continuity. If this point have cross section area A1 and this point have cross section area A2, then V1 and velocity of this point is V1 and velocity of this point is V2. Then V1 A1 will be V2. Here is a problem. You can see this is a very easy problem. You can solve easily. Okay. There is another theory which is most very important theory to explain the property of fluid dynamics. It's called Bernoulli's theory. Bernoulli's theory is basically a theory of conservation of total energy or conservation of work energy. The condition to maintain the Bernoulli theory means the fluid is incompressible, the fluid is non-viscous, the fluid flow in steady state, the fluid flow in irrotational. That means this is completely streamlined. So the fluid have some kinetic energy. As fluid is moving, it has some potential energy. If I take the potential energy at ground is 0, then if fluid moving upward, its potential energy gradually increasing. And another energy, pressure energy. We know the pressure energy is the pressure into volume. That means work done due to this pressure is called pressure energy, and this is called PV, P into V. Bernoulli theorem states that all this energy per unit volume is constant for any incompressible irrotational fluid. Okay. Pressure energy per unit volume will be P. Okay. And potential energy per unit volume will be rho gh, okay, m by v, and kinetic energy per unit volume is half rho v square. Okay. So the sum of these three energy is constant for any incompressible liquid. If I take a pipe having cross sectional area of the B and C position is A1 and A2, and pressure at the B position is P1, velocity of fluid is P1, and height of the B point is H1, and C point have also pressure is P2, velocity of fluid is V2, and height is H2. Then the total energy density That means energy per unit volume at the point B is equals to the total energy density at the point C. Okay, there is a proof. Just you can see the energy conservation of energy, that P plus rho G plus half rho is constant. So from this P plus half rho square plus rho G, if I divide the rho G, then we take another form of this equation called P by rho G plus d square by 2G plus H is equal to constant. This P by rho G is called pressure head. This P by rho G is called pressure head, and V square by 2G is called velocity head, and the H is called gravitational or potential head. Here is some applications of another is venturimeter tube or flow meter. By this tube, we can measure the speed of the flowing water of river or any other river or drain or any other different conditions. So this is the glass tube having different cross sections. One cross section is A1 and another cross section is A2, and this tube, another two small tube are connected with these tubes as shown in figure. Then the tubes, the vertical tubes, show the pressures of the points taking this point, and this pressure at this point shows by the vertical tube. That means H rho G. If H1 be the height of this tube, water height H1, and this is the H2, then H will be H1 minus H2. And also, if velocity of the fluid at point, this is V1 and this point is V2, then A1 V1 equals to A2 V2, or V2 equals to A1 by A2 into V2. From the Bernoulli equation for horizontal flow, we can apply Bernoulli equation at point. I take P and that point let Q. Okay. If I apply the total energy at P equals to total energy at Q, then we can find the rate of flow of liquid. Okay. That means P1 plus half rho V1 square equals to P2 plus half rho V2. And this P and Q have same horizontal level, so there is no potential energy difference. So only pressure energy P1 plus half rho P1 and contingent half rho V1 square equals to P2 plus half rho V2. By calculating this, we can find the rate of flow. Q with the volume of liquid flowing per unit area will be A1 P1 or A2 P2 equals to A1 A2 into A2. Just we have to remember how to calculate it. We don't have to remember this equation. Okay. Another application is speed of efflux for solution. If I make a hole on a vertical tube, then the liquid comes out and fall on a ground after some distance. This is called range. And the velocity of fluid coming out from the hole is called field speed of efflux. So this velocity can be calculated by the Bernoulli theorem. If I take 2 points, A and B, okay, B is this point, then at the point A, if the height difference between A and B is H, then at the point A, pressure is the atmospheric pressure P0, and the liquid have no velocity. That means no kinetic energy. That means A have only P0 plus also it has extra potential energy. It is called rho G H equals to, at the point B, it has potential energy 0. I have taken that it has potential 0, then it has potential energy rho G H. Then at the point B, there is also a atmospheric pressure P0 plus half rho square is the kinetic energy. Okay. P0 got out. Then we can calculate V equals to root over 2GH, which is same. If I drop a ball from height h, it reaches at, then it has velocity also root over 2GH. We know this is the same type equation. Okay. That means B point velocity have root over 2GH. And horizontal range of a flux. Horizontal range means how much distance the water touches the ground. This R will be V into T. If T be the time to reach the ground, then R will be V into T. Then we know T will be half GT square will be capital H minus small h. This capital H is the total height of the liquid, and this is the small h. That means this is the capital H minus small h. Then T will be 2 into capital H minus small h by G the root. Okay. Then the range will be R. R equals to T into T. That means root over 2GH into T will be root over 2 into capital H minus small h by G. This is the, then calculating this we can find this range of horizontal range of a flux will be 2 root over H into capital H minus small h. Then condition for maximum range. If I make a hole on a vertical tube, this point, this point, this point, see here the range is maximum for this point, and for this point range is decreased, and for this point also range is decreased. Okay. So to get maximum range, the height of the hole will be h by 2. H is the total height of the liquid, and height of the hole will be capital H by 2 is equal to. We can show that R equals to, here we calculate root over 2 into H into capital H minus small h. If I take R square, then it is 4H into capital H minus small h. If I different for maximum value of R square, d by dt of R square will be 0. Then I calculate that small h equals to capital H by 2. Okay. There is some other applications of Bernoulli's theorem here. We will discuss in next class. Okay. Goodbye.